Hello and welcome to the video number 6 of the cryptography series. If you are new to this particular channel or you are new to me, my name is Manoj Sharma and I am a CISSP instructor. My work is to make the entire cybersecurity like a cake for you, right? Now, this is video number 6 in the entire cryptography series. If you are somebody who like to go and understand cryptography in depth and other cybersecurity topics as well, there's a lot of stuff on this particular channel and a lot of valuable stuff, so do consider subscribing to this particular channel. In this video number 6 of cryptography, we are going to talk about two very important ciphers. One is called as block cipher and the another one is called as stream cipher. So let's dive in straightway into this and we will try to understand the nitty-gritty of this kind of cipher. So let's dive in. Hey guys, welcome everyone to the part 2 of cryptography, and here we are now going to talk about modern cryptography. When we say modern cryptography, that is the cryptography which we use today, as on today. So the number thing which we are going to understand, the number one thing is we are going to understand there are two different type of cryptography. One is block cipher and the another type of cipher we are going to understand is called as stream cipher. Okay, when we say block cipher, it is called as a block cipher because let's say I have a plain text, okay, and let's say this is 64 bits of length. Let's say it is the message is 64 bit. In block cipher, what we do, we actually break this entire message into equal part of block. For example, 8 8 8 8, right? Now what will happen is each block will independently go through substitution, transposition, or maybe in some cases XOR as well, that we will understand later, and then the final outcome will be your ciphertext. This is your plain text converted into ciphertext. These substitution and transposition, there are multiple rounds which happens. It goes in a circle like a mixer and grinder, right? It goes and take multiple revolutions. Like that it will happen here. It will churn the data out and will give you the outcome. So this is called as your ciphertext. Then the next block also will go through substitution and transposition and it will give us ciphertext. Okay, so this is called as your block cipher. In normal block cipher, the plain example which I described you, it is called as block cipher in ECB mode. It is also called as electronic code book. Electronic code book. It is the simplest form of implementation of the entire block cipher, and it is called as simplest because in this one every block is independently going through transposition and substitution. Problem with this is if a particular character is repeated here, like every time the particular 8 character, let's say this is CISSP and here also this is CISSP, it will always give me the same and outcome here A B C D E. Here also it will give me A B C D E. That's the problem state. So this kind of ECB mode is only used for very small message if your security requirement is not very high. It is super efficient obviously because no complication. It is just going through the normal process, so not more complexity here, no more processing here. It is very fast, but we will use it for very small message and where the secrecy required is not very high. Then this particular thing can also be enhanced further. What if the outcome of one block, so when one block goes with substitution plus transposition and it gives me with plain text, if I am going to take this plain text as an input for the next block, then outcome of one block as an input for the next block, like this. If I go like this, so it will form a chain. When we make this chain, it is called as cipher block chaining. an excellent way of making sure that your cryptography is strong. There are no patterns. Only one challenge. The challenge is, let's say your system faltered somewhere, and while making this particular block, there is some corruption in data happening. This corruption will also be carried away and all further blocks will get impacted, isn't it? So that's the only challenge. Otherwise, CBC board is perfect. It will prevent any kind of patterns in the data, in the ciphertext, right? Now we understood block cipher. Let's get on to stream cipher. But before we get on to stream cipher, let's see where we use block cipher. And block cipher is mostly used for data. Whenever you are storing data, whenever you are transmitting data, we use both the side, we use block cipher. For example, you are going to encrypt your hard drive. Which kind of cipher it is going to be? Block cipher. When your data has to go to your bank or maybe some other website and it is going through a secure TIS connection, we make use of block cipher. But is this sufficient enough for real-time communication? In real-time communication, latency is the biggest part, right? If latency is there, there is a problem, right? And when we make a data to go through this much stringent process, this much thing, and please remember, this is not one cycle. This may go with, let's say, 16 rounds of substitution and transposition. Your entirely data, let's say I am speaking to you, and if there is a delay for 1 second itself, this will create a lot of confusion for you. You will see my mouth moving and you will hear my sound later. That will be a lot of confusion, right? So in real-time communication, this block cipher may not be the best solution. For this, what we do, we make use of stream cipher. And how we do it is, let's say I am speaking to you in terms of 0 1 0 1 1 0 0 1 1 0, right? This is the bits which are going to you, right? There will be something called as key stream generator here, which will be randomly creating some zeros and ones. It will be generating some zeros and ones. And what will happen is, there will be a small mathematical formula which will be applied here, very, very light formula. This formula is called as XOR, extended OR function, which says that 1 and 0 will give you 1, 0 and 1 will give you 1, but 0 and 0 will give you 0, and 1 and 1 will also give you 0. Simple, that simple formula is applied on the bits by bits which has to be transmitted in real time. So not very process oriented, right? There will be very less delay and the data also will be encrypted. The end outcome will reach to the other side. The other side will also have the same key stream generator which will give those characters back. So there will be again XOR function happening here and they will be able to see the entire data, like they will be hear out everything. This is called as real-time communication. And in real-time communication, we use something called as stream cipher. The stream cipher is heavily used for real-time communication. Hey there, I hope you liked the entire video and this might have cleared a lot of your concept. If you really like it, please don't forget to subscribe to this particular channel and like and share with others as well, so that knowledge can spread, right? And with that said, this is just this is an entire series. Do not miss out watching other videos also. You might be getting those links. And with that said, I am going to see you in the next video.